Okay, so we are moving on to question 2 that was written by Noemie. So thank you very much for writing this question. I like this one too because I think this is also unique in a bit of a different way, which is that it's talking about volume. So it's not talking about kind of discrete items like magnet tiles or like dice or like socks or whatever. It's talking about little kind of liquids almost in the form of cream and sunscreen. So the basic idea, and I tried to draw it and I did a terrible job, is that there's a tube of sunscreen and a tube of cream, and you squeeze them both into a big bowl and then mix them all together. One important thing to keep in mind is the volume of the cream is 2/3 of the volume of the sunscreen. So I don't have the exact photo of the cream and sunscreen that Noemie made this problem up about, but I wanted to give you a bit of a visual example. And along with the theme of this day, of this past week's lesson, which was love. So that's a picture of a hand cream that is 60 milliliters. And then this is a sunscreen that is 90 milliliters. So you can see clearly that the cream has 2/3 of the volume that the sunscreen does. 60 is 2/3 of 90. So Noemie is going to squeeze both tubes into a large bowl, and that's going to be the basis for our probability problem. So our first up, what we're going to try to figure out is what's the probability if you take one tiny drop from the bowl that it's sunscreen? Or what about on the opposite side, what's the probability that it's cream? So the way I like to think about this, I don't know if you guys have seen this maybe when cooking, because this is sometimes something that's talked about in terms of recipes, but I'm going to use the word parts. Okay, I'm going to use this word parts to talk about how much of this is going to be cream and how much is going to be sunscreen. And what I've figured out from the fact that the volume of the cream is 2/3 the volume of the sunscreen is that it is going to be 2 parts cream and 3 parts sunscreen. Now, this word parts is kind of acting as a unit, but the nice thing about it, the cool thing, is that it could be anything. So for instance, if we wanted to, we could think about this in terms of ounces. So we could think that there are 2 ounces of cream and 3 ounces of sunscreen, and that would still work with our 2/3 rule. If you would prefer, we could also think about this in terms of liters or something, or you could even think of 20 milliliters and 30 milliliters, something like that. So once we know that it's 2 parts cream and 3 parts sunscreen, we want to think of probability, which again is successes over totals. So the probability of getting a sunscreen, I'll do that over here, is there 3 parts of sunscreen and 5 total parts, right? Including the 2 parts of cream as well. So our probability of getting a tiny little drop that is sunscreen would be 3/5. We could find our probability of getting a drop of cream in a couple different ways. First of all, we could think, well, we have to either get cream or sunscreen. Those are our 2 options. So it would be 1 minus 3/5, which is the probability that we get sunscreen, which is 2/5. You could also use the parts example and say, well, there are 2 parts cream over 5 parts total. And so our probability would be 2/5 either way. Okay, so here's the next part of this question. And again, I'm going to use kind of a case type of way of solving this problem. So if I'm taking 2 tiny drops and I want to know the probability that one is cream and the other is lotion, I'm going to split this into 2 cases. And my first case is that my first drop is cream. So the first one I pick up is cream. And then in case 2, which I'll write down here, the first one I'm going to pick is lotion. or sorry, not lotion, sunscreen. First drop sunscreen. And then of course in case 1, the second would have to be sunscreen so that, you know, we could follow the rules of the problem. And in the second case, the second drop would have to be cream. So now that we've set up our 2 cases, we have some probabilities to solve, and we're going to use our answers from this part of the question as well. So if our first drop is cream, the probability that our first drop is cream is going to be 2/5, as I said. Now this is where it gets really tricky. There's something a little complicated here, and it has to do with something I talked about in the last question. How our probability for pulling out that second small square was not the same as the probability for the first, because we are not putting, we're basically not putting that square back in the mix to be picked the second time. The thing that's really tricky here is we don't know how big a drop is, and so we don't know how much that affects our probability of getting sunscreen or cream the next time around. For instance, if our drop is really, really tiny, that would affect our probability not very much at all, and if our drop was huge, then that would affect our probability a lot. So what we're going to assume with this problem, what we're going to assume is that, I just saw that this said lotion, don't know why it says that, sunscreen. What we're going to assume is that it doesn't really affect our probability at all, because we're gonna assume that we took really big tubes and squeezed them into a really big bowl, and our drops are so tiny, maybe our drops are even molecules. So our best guess is that this is gonna affect the probability not at all. And so we're gonna guess that then the probability to get sunscreen next time is 3/5. In this case, the answer would be 6/25 as our answer. Our case 2 is going to be very similar. We're going to look at, okay, what's the probability that the first drop is sunscreen? 3/5. And then the probability that the second drop is cream, that's going to be 2/5. And remember, these probabilities and our denominators in particular are not changing because we're assuming that these drops are really, 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 really tiny. If we were taking really big drops, we would have to take that into account. But because the problem doesn't say how big these drops are, we're going to assume that they're basically 0. These drops are really, really tiny. Again, we get 6/25 for this. So our total answer is 6/25 plus 6/25. I can do the addition there, and I can say that's 12/25. So the final problem has to do with picking 2 drops that are both the same substance. So in this case, we don't actually matter. We don't care whether they're lotion or, I keep saying that. I don't know why I do that. We don't really care whether they're sunscreen or cream, but they just have to both be the same as each other. So we're gonna again split into cases. Our case 1 here is that they're both cream, and our case 2 is that they're both sunscreen. So in case 1, our probability of getting cream, and I can bring back this slide here. Our probability of getting cream was 2/5, and it's also going to be 2/5 approximately for that second drop. So our total here would be 4/25. In terms of sunscreen, our probability here would be 3/5 for the first drop and 3/5 as well for the second drop. And so total that would be 9/25. We'll add these together again. Remember, we're adding instead of multiplying because we're thinking of an or problem. It's either case 1 or case 2. So we're gonna add 4/25 plus 9/25, which is, you guessed it, 13/25. So an interesting fact that you may notice is that the probabilities here are actually very similar. So a cool question that you might be given is, which is greater, the probability that you get 2 drops where one is cream and the other is sunscreen, or the probability that they're both the same. The other interesting thing you might notice is that together they add to 1. So 12/25 plus 13/25 is equal to 1. And if you think about it, that makes sense, because when you pick 2 drops, you are either getting 2 that are different or 2 that are the same. So it would make sense for those 2 to add up to 1. All right, everyone, I hope you enjoyed this video series. Thank you again to Noemie and Sienna for giving me these amazing probability questions, and I'll see you guys next time.